Let me introduce myself. I am Raphika, Associate Professor, Department of Electronics, MES College, Marampally.
Welcome to this session, Introduction to Microprocessor. In this session, I would like to introduce Intel 8085 microprocessor and its internal architecture and register organization. A microprocessor is an electronic component that is used by a computer to do its work. It's a multi-purpose, clock-driven, register-based digital integrated circuit which accepts binary data as input, process it according to the instructions stored in its memory, and provide results as output. Microprocessor includes all the logic circuitry on one chip that contain millions of transistors. It is responsible for all the processing done in a computer. The microprocessor system organization consists of a control unit, input-output unit, and memory. The main components of a microprocessor is arithmetic and logic unit, register array, and control unit. The ALU is the unit of a microprocessor where various computing functions are performed on the data. It performs arithmetic and logical operations such as addition, subtraction, logical and or etc. The results are stored either in registers or in memory or sent to the output device. It is also known as the brain of the computer. The register unit is the area of the microprocessor which has various registers. The registers are used primarily to store temporary data during the execution of the program. Some of the registers are accessible to the user through instructions. The control unit provides the necessary timing and control signals to all the operations in the computer. It controls the flow of data between microprocessor and peripherals. Let me introduce Intel 8085 in detail. The 8085 is an 8-bit general-purpose microprocessor which has 40 pin and it has 8 data lines and 16 address lines, and it can address up to 2:16 memory locations. The clock frequency of 8085 is 3 MHz with a plus 5-volt power supply. It's a single chip NMOS device implemented with 6200 transistors. It provides 74 instructions with the 5 addressing modes. The 8085 CPU communicates with the other unit using 16-bit address bus, 8-bit data bus, and control bus. The address bus consists of 16 address lines A0 to A15. It operates in unidirectional mode. The address lines are always sent from MPU to peripheral device. The 16 address lines are capable of addressing a total of 64K memory locations starting from 0000 hex to FFFF hex. The database consists of 8 data lines D0 to D7 and is operate in bidirectional. That is, the data bits are sent from MPU to peripheral devices as well as from the peripheral device to MPU. The data range from 00 hex to FF hex. The control bus consists of various lines carrying the control signals such as read, write, enable, and flag bits. The address lines are used to transfer 16-bit address of memory as well as 8-bit address of I/O ports. The address bus has 8 signals A8 to A15 which are unidirectional. The other 8 address lines are multiplexed with the 8 data lines. So the bits AD7 to AD7 to AD0 are bidirectional and serves as A0 to A7 and D0 to D7 at the same time. There are four main control and status signals. One is ALE, the address latch enabled, which I will explain in detail later. The others are RD bar, that is a read bar signal. It is active low signal, which indicate that the selected IO or memory device is to be read and also is available on data bus. Right bar is the active low signal, which indicate that the data on data bus are to be written into a selected memory location. IO bar M bar that distinguish IO operation and memory operation, and if IO bar M bar is 0 for memory operation and 1 for IO operation. S0 and S1 the status signals to specify the kind of operation being performed. The ALE address latch enable is used to enable or disable the external latch, and it is used for demultiplexing AD7 to AD0 lines, that is used to separate address and data from AD7 to AD0. If ALE is 0 or 1, then external latch IC is enabled or disabled respectively. Now let me explain the internal architecture of Intel 8085. The microprocessor is a programmable logic device designed with registers, flip-flops, and timing elements. It has a set of instructions designed internally to manipulate data and communicate with the peripherals. The process of data manipulation and communication is determined by the logic design of the microprocessor called its architecture. The architecture of 8085 is capable of performing the following operations: store 8-bit data, perform arithmetic and logic operations, test for conditions, sequence the execution of instructions, store temporary data in RAM during execution. This is the internal structure of 8085. The ALU is connected to accumulator, temporary register and flag register, and 8-bit internal data bus is connected to other than ALU instruction register and instruction decoder, and all are connected to the timing and control signals, and a set of registers, special purpose and general purpose registers, address bus for A8 to A15, and address and data bus for AD0 to AD7. The registers of 8085 A, B, C, D, E, H, L, F. The general purpose registers, temporary registers, and special purpose registers in B, C, D, E, H, and L are 8-bit registers, and it can be used as 8-bit registers individually and register pairs like B, C, D, E, and H, L. Temporary registers are temporary data register and W and Z registers. Special purpose registers are accumulator, flag register, instruction register, program counter, and stack pointer. Registers B, C, D, E, H, and L are general purpose 8-bit register used to store data temporarily during the execution of the program. It is possible to use these registers as register pairs like B, C, D, E, and H, L. Accumulator is a special purpose register used to perform all the arithmetic and logic operations. And after the execution of the arithmetic and logic operation, the result is stored in accumulator. If an arithmetic or logical operation involving two operand, one of the operand should be in accumulator. The special purpose register, one of the special purpose register is flag register. The flag register is an 8-bit register out of which 5 of bits carry significant information in the form of flags. The five flags are S sign flag, Z zero flag, AC auxiliary carry flag, P parity flag, CY carry flag. The sign flag is the after the execution of arithmetic and logic operation. If bit D7 of the result is 1, then the sign flag is set. In a given byte, if D7 is 1, the number will be viewed as a negative number, and if D7 is 0, the number will be considered as a positive number. S flag, Z flag, 0 flag. The 0 flag set if the result of the operation in ALU is 0, and the flags reset if the result is non-zero. The 0 flag is also set if a certain register content becomes 0 following an increment or decrement operation of that register. AC auxiliary carry flag, this flag is set if there is an overflow out of bit 3, that is carry from lower nibble to higher nibble, D3 bit to D4 bit. The flag is used for BCD operation and it is not available for the programmer. Parity is defined by the number of ones present in the accumulator. After arithmetic or logical operation, the result has an even number of ones, that is even parity. The flag is set, and if the parity is odd, the flag is reset. The carry flag is the flag if there is an overflow from a bit 7. The carry flag is also serves as borrow flag for subtraction. Other special purpose registers are program counter and stack pointer. Program counter is a sequence of instructions. Program is a sequence of instructions and microprocessor fetch these instructions from memory and execute them. The program counter is a special purpose register which at a given time store the address of the next instructions to be performed. The stack pointer, the stack is the reserved area of the memory in, in a RAM where the temporary information may be stored. A 16-bit stack pointer is used to hold the address of most recent stack entry. Other than program counter and stack pointer, the instruction register is another special purpose register. It is a typical processor operation. In a typical processor operation, the processor first fetches the opcode of instruction from memory, and the CPU stores this opcode in a register called instruction register. This opcode is further sent to the instruction decoder to select one of the 256 alternatives. Temporary data register. The ALU has two inputs. One input is supplied by the accumulator and other from the temporary data register. The programmer cannot access this temporary data register. However, it is internally used for execution of the most of the arithmetic and logic instructions. W and Z registers are temporary registers. These registers are also used to hold 8-bit data during the execution of the some instructions. Let me conclude the microprocessor is a multi-purpose clock-driven register-based digital integrated circuit which accepts binary data as input, process it according to the instructions stored in its memory and provide the results. Thank you.